Okay. Hi, everyone. Welcome to our workshop on program upgradability. For those of you who don't know who I am, my name's Alex. I'm the developer relations lead from the Aleo Network Foundation. I kind of been around on Discord and running workshops, being in the dev community, and now I'm up here running the workshop. So happy to be here, and hopefully this will help some of you out. Okay, here's some useful links for everyone. Our website is aleo.org. Our link to our Discord, where we have a lot of events and community outreach and things like that, is right there. We'll have a link to this workshop, so the slides and all the code that we go through. I have a repo on GitHub, um, and if materials aren't showing up now, they will show up in the next immediately after this presentation. And finally, relating to upgradability, we have a set of docs that you can go look at for more information. So that's at developer.aleo.org, as well as docs.leolang.org. And we have a devs telegram as well. Give everyone a second to take that down. Okay. So what's kind of the agenda today? So we're going to go over an overview of what program upgradability is. Just kind of go through what the motivations are and why we chose to do it the way we did. We'll go through some upgrade syntax, so some new operators and syntax you'll need for program upgradability. We'll go through some common upgrade patterns recommended by us and by the people at Provable. We'll go through a live demo showing exactly how program upgradability works and how you could do it. And then we'll go through some limitations on what you can and can't change in your program, and then as well as some security considerations. Okay, so what is program upgradability? As you might be able to guess from the name, it's the ability to upgrade your programs. So, a way to kind of edit the functionality and logic of your already deployed programs without needing to redeploy a second copy. So prior to this, if you deployed a program on chain, you saw there was kind of a bug or an undesired feature, what you'd have to do is, make any changes you want locally and then redeploy a second copy and then have everyone migrate over. This obviously kind of breaks the user experience, and it's just not desirable. So moving forward, this feature allows you to not have to redeploy. And it's all kind of centered around this idea of something called a constructor function. So this is a function that gets run anytime a deployment or upgrade gets called on your smart contract. So it's run when your initial deployment happens, as well as every successive upgrade attempt. So there's kind of two key properties here of the constructor. It's kind of foundational. So all new programs starting with this, network upgrade must be deployed with a constructor function. So if you try to deploy without a constructor function, the deployment will fail. And in addition, if the logic, whatever upgrade logic you've written inside your constructor, if that fails, then the deployment or upgrade transaction is rejected. And you can kind of think of it as like the gatekeeper for your program. The second kind of property is it's immutable. So you can upgrade a lot of different functions within your program, but the constructor itself is fixed. So once after your first deployment, once that whatever logic is in there, it cannot be changed by any future upgrades. So make sure you audit it pretty intensely. Okay, so why did we do this? Like, what is the point of program upgradability? And I kind of alluded to it earlier, but here's a kind of a concrete example. So let's say you had a program called dex.aleo deployed on chain. It's very kind of straightforward. Many of you are familiar with a dex, but you have some kind of functionality that lets you deposit funds into the pool, so you can maybe earn yield, something like that, and then you can trade between different token types. So token A to token B, something like that. So the deposit function will obviously take in liquidity to the pool, and the trade function will let you swap between different tokens. But let's say you find a bug in your trade function. There's some feature that lets people just drain the liquidity from the pool or get some undesired effect. Previously, if you wanted to fix that bug, like I said, you'd have to fix the bug locally and then redeploy a second copy, in this case called dex2.aleo, and then let all your users know and provide a way to migrate all that liquidity from the first program to the second program. And like I said, this just completely breaks the user journey and is not desirable. So with our new feature of program upgradability, you'll be able to keep all the liquidity in your original program, make the fixes you need to patch the vulnerability, and push those changes to the originally deployed program without needing to have multiple copies. Okay, so here's kind of the new syntax you need to be familiar with for program upgradability. There's a couple new operands. So first one is called self.addition. Every program now essentially has a version number to go along with it. So it'll start at 0. So whenever you initially deploy a program to the network, it'll be version 0. And every time it gets upgraded, it's incremented by 1. You will not need to keep track of this as a developer. This is automatically tracked by the network. So you can just query this information inside your constructor, for example. The second one is also pretty straightforward. It's self.program owner. So whatever address that deploys the program initially gets stored in self.program owner. The last one is a little less clear, but it's actually pretty important. So it's called self.checksum. So the program's checksum, as it says there, is a unique identifier for your program's code. And in particular, you can kind of think of it like a hash value. So, if you have some kind of checksum of your program, if you change one little piece of the input or one character in your program, then the entire checksum will change. So it's a very unique kind of fingerprint for the exact code that's in your smart contract. And the usefulness I'll show in the next slide here. So we have 4 primary upgrade modes that are in this update. The first one is called no upgrade, and these, I should mention, this syntax are used as decorators on top of your constructor function. I'll show an example in the next couple of slides here. So the first one is no upgrade. So that's if you want to completely ossify your program and make it not upgradable at all. Pretty straightforward. The second one's an admin-based upgrade. So if you want upgrades to be restricted to only a single administrator address, so only one person or one address can call the constructor function or call upgrades on your smart contract. The third one is, like I mentioned before, this checksum. So let's say if you wanted to have your upgrades, governed by this on-chain checksum. So think of kind of like a DAO. If you wanted to have a DAO contract that votes on a certain, new version of a treasury program or something like that, and you get the checksum of that upgraded treasury, have the DAO vote on it, store it in some kind of mapping, and then this constructor could query that mapping to find the approved checksum. I'll show an example of this again in the next couple slides. And the final mode is actually this custom upgrade mode, where you can just have any kind of upgrade logic you want from scratch, and you write it in the constructor. So let's go through a couple examples here. First one is pretty straightforward. It's the no upgrade. Nothing much to it, just denote it as no upgrade. Again, it's that decorator on top of your async constructor, and there doesn't really need to be any logic in there. The second one is this admin-based upgrade. So it will be denoted by the admin decorator, and then you'll provide this address inside that decorator, and then whatever Aleo address you want to govern or want to restrict the constructor to. The third one is this checksum-based upgrade. So like I said, if you have a contract called DAO.aleo, for example, you could have a mapping in that DAO contract that has the approved checksum in it, and check to make sure that the key for that mapping is true, essentially. So you essentially, have the DAO vote on what the new program will be in its checksum form, but make sure the vote is true, and then refer this constructor to that mapping. And finally, we have this kind of custom upgrade pattern. In this case, we're giving a time lock example. So, assuming the addition of the program is greater than 16, excuse me, greater than 0, if it's anything past the initial deployment is what that means, then you want to assert that the block height is past a certain value. So you're restricting the time that the constructor is allowed to be called past above a certain block height. And this is just one example of the custom constructors you can write. Okay, so you've seen kind of the examples and the high level overview. Let's kind of get into a real live example here. Switch windows, if you give me 1 second. Okay, so I've deployed a couple of just pretty standard token programs, like very, very simple, nothing much to it. And it's what you would expect for a token. You can mint, you can call transfer, things like that. So let's say you had a DEX program, just like earlier, the one at main example I mentioned earlier. I've kind of written out a standard DEX contract, add liquidity, swap token 1 for token 2, swap token 2 for token 1. Very, very straightforward kind of DEX program. So let's say this was deployed on chain. And a typical kind of approach that some developers take is like, if you're testing your program and a certain feature is not working, what you'll do is kind of have a return true function inserted into a certain part of your contract here. So let's take this example. So if you had an assert kind of believe, normally you'd have like an assert, balance of user is above a certain amount. So give me 1 second. Let's take token 1 source main, and I guess a better way to do this is here. So normally here, so let's say we have the user transfer. Normally you have a check to make sure, obviously, the user has enough funds, right? In this case, this is the user, this is DEX, same kind of logic here. But when in the course of testing your program, let's say you don't want to do these checks, you want to just make your program return true for testing purposes. Let's say you commented this out, and then you forgot to uncomment it out later, and then you go to deploy. It should work fine. It should work great. So let's go to token 1. And say second. Maybe I'm just going to grab the address for the admin account. So we I'll deploy this constructor here for now, just to for an example. So we have our token one. Called token one beta. And then what we'll do, I have a devnet spun up here. So we'll deploy Leo devnet, Leo deploy devnet dash y. Ah, another example of why our name is too long. So let's call it just token. Ah, broadcast. Okay, so our deployment is confirmed. Our token has been deployed on chain, but there's a problem. We forgot to check that a sender had enough funds to transfer. In this case, in the DEX example. So you essentially you have a bug in your program, and normally, as before, you would have to completely redeploy this token contract. Which, if there's a dependency in the DEX, then you'll have to redeploy the DEX and refer it to the new token contract, and it cascades into this example of just not being feasible. So let's say we make our change here. We have our new version of upgradability workshop. So then if we call Leo upgrade devnet, and we can see it confirms the upgrade. So walking through this just a little more closely, it's very similar to Leo deploy. So if you are in fact the admin in this case, I put in the DevNet pre-funded address. So this is the address I'm controlling. You have enough tokens to fund this transaction, and it will check to make sure that you are the admin. Make your changes to the program. You'll see that it'll be broadcast to the network. And then if we do Leo query program upgradability workshop token Aleo. In the wrong syntax, I believe. It always goes wrong in the lab demos. Okay, this may be an issue with the DevNet, but we can kind of see that the transactions were in fact broadcast and then checked to make sure that the transactions were accepted, and it confirmed the upgrade. So that's kind of, I mean, it's pretty straightforward. It's nothing too fancy here. Let me see. There was a mess. Okay, so let me switch back to the presentation. Okay, so m- there are some limitations to what you can and cannot upgrade. So for obvious reasons, you cannot delete any existing program components. So you'll never be able to remove any kind of function, like remove any functions or structs or mappings or anything for compatibility reasons. You also can't change the logic within any non-inline function. So again, if you have just your function foo and whatever logic is in there inside this green box here, you will never be able to change, and that'll just remain static. In addition, you can't modify any existing structs, records, or mappings. So you can't change any of the fields, the types, um, anything of that nature. Again, for compatibility reasons. You also can't modify any input or output signatures of any existing transitions, functions, or async transitions or async functions. So when I say input or output signatures, I mean anything in the kind of first line. So the name of the function, the inputs and outputs and their types, and anything of that nature. And here's kind of a nicer chart. You can find this on the docs um, link. This kind of exact chart is explaining what's upgradable and what is not upgradable. Okay, and lastly, we have some security considerations. So as mentioned earlier, the constructor is fixed when you deploy it. So please audit your constructor very intensely and make sure it's doing exactly what you want it to do. Prefer multi-sig or DAO governance over a single admin address, again, for decentralization and security. Try to implement some time locks for major upgrades, and plan for ossification. So provide ways to make your program immutable after maybe a certain period of time, after a certain block height. Maybe have an address that governs upgrades, but eventually, after a certain amount of time, burn that address so no one will be able to upgrade it, and no one will be able to just come in and if the key gets leaked and completely destroy the program. That's all I have so far.